Alright. So if you'll remember back to last semester, we talked about, y'all remember SSS postulate? Side postulate? Remember SAS postulate? Remember ASA? What else do we have? HL, all that. Well, today we're going to talk about 3 of those today. 2 of those today, same thing, but we're going to add one. But they don't have to do with triangle congruency, they have to do with triangle similarity. Okay, last week we talked about polygons being similar to each other. And for 2 polygons to be similar, what had to happen? Well, this is what had to happen. Your sides of that polygon had to be the same ratio all the way around. They had to be in proportion with each other. Okay, for 2 polygons to be similar. Okay, and we talked about what similar was. Same shape, but not necessarily the same size. Okay, all right. Well, today we're going to talk about triangle similarity. And if you'll know, if you'll remember this, triangles are still polygons. Okay, they're a multi-sided figure. They're still a polygon. So we're still going to have proportionality involved in this. Okay, but we're going to add 3 things to that. Okay, and let's talk about the first one. The first one is the AA similarity postulate. AA, of course, stands for angle. And what it says is this. It says if 2 angles of one triangle are congruent to 2 angles of a second triangle, then the triangles are similar to each other. And that stands for similar. This sign right here stands for similar. Okay? And actually the word, y'all know what that stands for? Congruent, right? Well, congruent means this, similar and equal. Okay? And we're going to take that equal sign off because they're not going to be equal today. They're going to be similar to each other. All right? So, 2 triangles of one triangle are congruent to 2 angles of a second triangle, then the triangles are similar to each other. Okay, and I've given you an example right here of 2 triangles that either are similar or aren't similar. And all we're going to look at is the angles in these 2 triangles. And we notice that this angle right here is equal, but are these 2 angles equal to each other? No, they are not. But these 2 angles don't correspond to each other either. They're not the same angle. But I know that I do have an angle here that corresponds to this angle here. And what I have to do is I have to reflect back. If I add up all the angles of a triangle, what angle should I get? What's the degrees should I get? 180. If you'll take your handy dandy calculator and you'll take 49 plus 92 and add it together and subtract it from 180 degrees and tell me what this angle is going to be equal to. What's this angle going to be equal to? I got 49 plus 92.
It's going to be 39.
It's going to be 39. Now, if you'll notice something, does this angle and this angle correspond to each other? Are they the same angles? Yes, they are. So I have this angle is equal to this angle, and this angle is equal to this angle, and probably this angle is equal to this angle, but all I got to have is 2. So, in theory, these 2 triangles are similar to each other based on 2 of their angles being equal to each other. Okay? Now that is triangle similarity AA, angle. Moving on to the next one, we have SSS. What did SSS stand for when we talked about triangle congruence? Side. Okay? And what this theorem says is this. If 3 sides of one triangle are proportional to 3 sides of a second triangle, then the 2 triangles are similar. Okay? Let's go back to the past here. Let's go back to wagging up. When we talk about congruence, it said this. If 3 if three sides of one triangle are congruent to three sides of a second triangle, then the triangles are congruent. Here's the key word you have to remember here. It's saying proportional. Proportional. What shows proportionality? I got to show that these two triangles are in proportion. So what am I going to do? I'm going to set up the ratios. Okay? And I have to do it with corresponding sides. So if you'll notice these two triangles here, 8 corresponds to what side over here? 15 or 10? 10. Okay, so watch this. To show proportionality, I'm going to say 8 is to 10. Okay? And then I'm going to reduce that fraction. Okay? 8 over 10 reduces to what? 4 over 5. Okay? And then I'm gonna set up the ratio 12 is to what over here?
12 is 15.
12 is to 15. And I'm going to reduce that ratio. 3 goes into both of those, right? Do those two ratios equal each other?
Yes.
Yes, they do. Therefore, I have a proportion here. All these sides are in proportion. So if I can prove that these sides are in proportion, guess what? These two triangles are similar to each other. If I get one ratio that's out of whack.
This interruption at this point. This is shelter in place hazmat. This is shelter in place hazmat. Please follow the expected procedures. Once again, this is shelter in place hazmat.
What that mean?
I don't
That
know.
means stay in the classroom. Hush.
You have to take the classroom?
Stay in the classroom.
Oh, I'm on the way.
Stop being scared, bro. I think I'm going home. Oh. You got TikTok? Hey, y'all know
All right. I'm going to keep teaching. All right. Last but not least, we have SAS. What did SAS stand for when we talked about congruence? Side, angle, side. And it said this when we talked about congruence. It said, if two sides and the included angle of one triangle are congruent to the two sides and the included angle of a second triangle, then the two triangles are congruent. You need to understand where included is. If I got a triangle here, and I'm talking about this angle and this angle, where is the included angle? Is it this side? Is it this side? I mean, where's the included side? Is it this side? Or is it this side? Or is it this side? It would be the side between the two angles. So it would be this side right here. Okay? Again, side angle side, I got this side, it's going to be the angle in between the two sides. Okay? All right? It says this, if two sides and included angle of one triangle are in proportion to two sides and included angle of a second triangle, then the triangles are similar. So all we got to do is show two angles are congruent to each other, and two sides are in proportion. Good Lord.
You got the clock?
Excuse me?
I said the clock, bro. You know what I was really going to say. Okay, I said clock. You should definitely say clock.
Okay. So looking at this one right here, y'all see those two angles right there? Are they congruent to each other?
Which one would?
These two angles right here. Are they congruent to each other?
No.
Yes, they are, because they are vertical. They are across from each other. So this angle equals this angle. So I got the angle part taken care of. So now that got that, I need to prove that the sides are in proportion. So, what side does 16 match up with over here, 24 or 27?
27. You said size 16 matchup.
16 matches up with 24 or 27. You gotta flip it.
24.
It's 24. So I'm gonna go 16 is to 24, and I'm gonna go 18 is to 27. I've set up my ratios. Now I gotta see if those ratios are equal to each other. And I'm going to reduce that. 16 and 24 have what in common? 8.
Mm-hmm.
That gives me 2/3. Okay? 18 and 27 have what in common? 9. Are those equal to each other? If they're equal to each other, then I have SAS and these two triangles are similar to one another. Okay? Anybody have any questions about that? All right, moving over this way. Sometimes you might be asked to find X. In using ratio, we can do that. So all we gotta do is set up two ratios and make them equal to each other and cross multiply, or do the butterfly, okay, and find X. That's all we gotta do. So this is how we're gonna do this. That side matches up with that side, right? So I'm gonna say 10 is to 15. Okay? As X plus 11 is to what? 20. My proportion is set up. Now to solve my proportion, all I gotta do is cross multiply. Okay? So I'm gonna go 15 times X plus 11 is equal to 200. All clear. Thank you.
At this time, we're all clear. Teachers and students, thank you. Teachers, I will be sending an email. If you would please read your email to review some of the procedures so that we can make sure that we are all aligned. Thank you again.
What's 15 times 11, somebody? 165? Okay. How do I get rid of that 165? Subtract it. That's gone. That gives me 15x equals 35. And how do I get rid of that 15? I divide. And I get x equals 2.33, or 2 1/3. So the missing side here, x plus 11, is 2.33, that's x. If I wanted to find that side, I'd take 2.3 and add it to 11. Okay? Alright, next one, a little more difficult. How many triangles you see here? How many triangles you see? I see 2.
2.
Okay? Alright, I see this small triangle and I see this big triangle. Okay? Those two triangles are similar to each other. I gotta find out what x is. So I'm gonna start with my small one. 6 is to what? This small side is equal to this big side, or is in proportion to this big side. What's this big side gonna be equal to? 12, or 6, or 18?
18.
18. So I'm gonna say 6 is to 18. Everybody see where I got that? As x is to what? This whole side is 24. Now I'm gonna do the butterfly, the cross multiply method. 18 times x is 18x. 6 times 24 is 144, right? divide by 18. And what's X equal to? 8. Okay. X is equals to 8. So this is 8. What's that whole side gonna be, or what's this side gonna be equal to? 24 minus 8. That's what that's gonna be equal to. Okay? Yes, ma'am. Not right this minute. Not right this minute.
Right away.
You can't go anywhere until I'm finished.
I'm finna go home though.
Well, okay, when they call you, I'll let you go. All right? Anybody have any questions?